Earth that represents both the grandeur and impermanence of stars. Yet, in recent years, Betelgeuse has become more than just an astronomical landmark. It has ignited a wave of speculation and urgency within the scientific community. Once considered a relatively stable fixture of the night sky, Betelgeuse is now exhibiting signs of highly unusual behavior that hint at the possibility of an imminent supernova. A rare and spectacular event that would both illuminate the heavens and challenge humanity's understanding of stellar evolution. Astronomers have long known that Betelgeuse is nearing the end of its life cycle. As a red supergiant, the star has burned through its nuclear fuel at a staggering rate, a trait that inevitably leads to collapse and explosion. Traditionally, this process spans hundreds of thousands of years, offering a comfortable buffer against cosmic catastrophe. However, data from the James Webb Space Telescope, JWST, and other observatories have revealed anomalies that suggest the timeline might be accelerating. Over the past several years, Betelgeuse has undergone dramatic dimming episodes, unexpected spikes in brightness, and massive ejections of matter from its outer layers. These phenomena, once considered isolated incidents, are now being reinterpreted as potential precursors to a supernova. The JWST, with its unparalleled infrared sensitivity, has provided scientists with an unprecedented window into Betelgeuse activity. Observations have captured surges of thermal energy and mass ejections of plasma from its surface. Events that dwarf even the most powerful solar flares observed on our Sun. One such surface mass ejection was so immense that it expelled material equivalent to over 400 billion times the mass of a typical solar flare. An astonishing feat even by stellar standards. Such findings have led to a growing consensus that Betelgeuse is shedding its outer layers at an accelerated rate. A process that could signify the final stages of its evolution. What makes this situation even more compelling is Betelgeuse's relative proximity to Earth. Located a mere 642 light-years away, its eventual supernova would be unlike anything seen in recorded history. Predictions suggest the explosion could rival the full moon in brightness, dominating the night sky for weeks and even being visible during the day. This would be a breathtaking spectacle for observers. But it also raises important questions about the potential impacts on Earth and its surrounding systems. The energy released in a supernova of this magnitude could result in a burst of radiation that temporarily affects Earth's magnetosphere, potentially disrupting satellites, power grids, and communication networks. While these disruptions would likely be temporary, their economic and logistical challenges could be significant, particularly for industries that depend heavily on space-based technologies. Despite the excitement and concern surrounding Betelgeuse, predicting the exact timing of its explosion remains one of modern astronomy's greatest mysteries. Forecasting a supernova is an incredibly complex task, as the physical mechanisms governing such events are still not fully understood. The JWST's data is helping to refine existing models by allowing scientists to analyze the chemical composition of the material ejected from Betelgeuse and track its energy fluctuations. Researchers hope to identify patterns that could offer a more accurate timeline. This effort represents a monumental step forward, as no supernova in human history has ever been observed in real time with such advanced instruments. The implications of Betelgeuse's eventual supernova extend far beyond any immediate effects on Earth. The explosion will release vast amounts of energy and heavy elements like gold and uranium into space, contributing to the cosmic cycle of matter that seeds nearby star systems with the building blocks of planets and potentially life itself. Studying this process in detail could provide valuable insights into the origins of our own solar system and the conditions necessary for habitability elsewhere in the universe. Moreover, the event could offer a rare opportunity to test and refine theories about the formation of neutron stars and black holes depending on what remains of Betelgeuse after the explosion. However, the prospect of Betelgeuse supernova also highlights humanity's vulnerabilities in the face of cosmic forces. A large enough burst of radiation could disrupt the delicate balance of our technological infrastructure. Satellites, which are crucial for GPS navigation, weather forecasting, communications, and countless other services, could be damaged by high-energy particles. Power grids, already susceptible to geomagnetic storms caused by solar activity, might experience widespread outages if Earth is exposed to a surge of radiation. To mitigate these risks, organizations like NASA and the European Space Agency, ESA, are developing contingency plans that include radiation shielding for satellites and adaptive technologies that can adjust orbits in response to changing space conditions. While scientists work to prepare for these potential risks, Betelgeuse's erratic behavior has also sparked deeper philosophical and ethical debates. The explosion of a star of this magnitude would undoubtedly yield a wealth of new scientific data. But it also raises questions about the ownership and use of such knowledge. Who controls the discoveries made in the aftermath of the supernova? Could a newfound understanding of heavy element formation or radiation shielding be used in ways that exacerbate inequality or even fuel military conflict? These concerns underscore the need for international collaboration and transparency in studying Betelgeuse and other celestial phenomena. The unpredictability of Betelgeuse behavior has also forced scientists to confront the limitations of current astrophysical models. The star's recent activity, including unexplained temperature fluctuations and strange chemical signatures in its outer layers, has defied expectations and suggested the presence of physical processes not yet understood. These anomalies could point to entirely new mechanisms at play in the life cycles of massive stars, challenging long-held assumptions about stellar evolution and the forces that shape the universe. As humanity awaits the next chapter in Betelgeuse's story, the star serves as both a reminder of the universe's beauty and a harbinger of its unpredictability. Whether the supernova occurs tomorrow or centuries from now, the lessons learned from studying Betelgeuse will resonate for generations. This celestial giant poised on the brink of transformation embodies the duality of creation and destruction that defines the cosmos. It challenges us to look beyond our immediate concerns, to prepare for the unknown, and to embrace the opportunity to learn from one of nature's most awe-inspiring phenomena. Betelgeuse's fate is not merely an astronomical curiosity. It is a test of humanity's ability to observe, adapt, and respond to the mysteries of the universe. The data collected in the lead-up to its eventual explosion will shape our understanding of the stars and our place among them, offering a glimpse into the forces that have shaped the cosmos since its inception. In this way, Betelgeuse reminds us that while the universe is vast and often incomprehensible, it is also deeply interconnected with every star and planet contributing to the larger story of existence. As we watch and wait, the countdown to Betelgeuse supernova becomes not just a scientific pursuit, but a testament to humanity's enduring curiosity and resilience. This fiery red supergiant has fascinated generations with its brilliant glow. But now, thanks to unprecedented observations from the JWST and other cutting-edge observatories, we have begun to see it in a new light, one that reveals both the staggering power of the universe and our own capacity to understand it. The JWST's advanced infrared capabilities have revealed extraordinary activity around Betelgeuse, intense heat surges, dramatic fluctuations in brightness, and massive surface mass ejection, suggesting the star is shedding its outer layers at an unprecedented rate. One particularly enormous mass ejection was recorded as releasing over a billion times the energy of a typical solar flare, a phenomenon never before observed in a red supergiant. Such events are hallmarks of a star nearing the end of its life as it exhausts its nuclear fuel and collapses under its own gravity. When Betelgeuse finally goes supernova, the explosion will be a spectacle unlike anything witnessed in recorded history. The blast will likely outshine the full moon, illuminate the night sky for weeks, and even be visible during daylight hours. Shock waves from the event will ripple through space, carrying energy and matter that could affect nearby star systems. While Betelgeuse is around 640 light-years away, a safe enough distance to prevent catastrophic damage to Earth, the sheer scale of the explosion would still have important consequences for our planet. One immediate concern is the effect of the supernova's radiation. High-energy particles and electromagnetic waves could interact with Earth's magnetosphere, triggering geomagnetic storms capable of disrupting satellite communications, GPS systems, and power grids. These disruptions, while likely temporary, could have significant economic and logistical consequences, particularly in an era so reliant on space-based technology. Yet, the scientific opportunities presented by such an event are unparalleled. Observing Betelgeuse supernova in real time would offer critical insights into stellar evolution, the formation of heavy elements, and the mechanisms behind asymmetrical stellar explosions. These observations could help refine models of black hole and neutron star formation, shedding light on the mysterious processes that govern the universe. Moreover, Betelgeuse's explosion would not just be an astronomical event, but a cultural one. Throughout human history, the night sky has inspired wonder, mythology, and exploration. A supernova visible to the naked eye could reignite our collective fascination with the cosmos, fostering renewed global interest in science and space exploration. Despite these thrilling possibilities, significant uncertainties remain. Predicting the exact timing of a supernova is notoriously difficult. Even with the most advanced data and models, Betelgeuse's explosion could still be decades or centuries away. This unpredictability underscores the importance of continued monitoring and international collaboration. Agencies like NASA and ESA are developing advanced predictive models and contingency plans to mitigate potential risks. These efforts include shielding satellites from increased radiation and ensuring critical infrastructure can withstand geomagnetic disturbances. Additionally, scientists are working to ensure global observatories are prepared to capture the wealth of data such an event would generate, combining cutting-edge technology with human ingenuity to unlock the secrets of one of the universe's most dramatic phenomena. As we await Betelgeuse's ultimate fate, its story serves as a powerful reminder of our place in the cosmos. Its eventual demise will not only reshape the night sky, but also deepen our understanding of the life and death of stars. Whether it happens tomorrow or centuries from now, the legacy of Betelgeuse will endure, challenging us to explore, learn, and marvel at the universe that gave rise to